All these three protocol comes under a category called first hop redundancy protocol. First hop route redundancy protocol. In that, hot standby routing protocol or hot standby redundancy protocol, இந்த ஆருக்கு நீங்க ரவுட்டிங்னு சொன்னாலும் தப்பில்லை, redundancyன்னு சொன்னாலும் தப்பில்லை. இல்ல hot standby route redundancy protocol சொன்னாலும் நல்லதுதான். route redundancy அதான் இங்க வரும். virtual route redundancy protocol. gateway load balancing protocol. load balance பாருங்க, load balance இதுல மட்டும் தான் S போட்டிருப்பான். ஆமா, ஏன்னா இந்த லோட் பேலன்ஸ் பண்றதுக்கு நம்ம வந்து GLBP தான் எனேபிள் பண்ணணும். மற்றதெல்லாம் HSRP கதையில என்ன வந்துச்சோ அதே கதை தான். ரெண்டுமே சிஸ்கோ கதை, சேம் கதை. ரெண்டுமே ரெடண்டன்சி. இதுல ஒரு ஆக்டிவ் இருக்கும், ஒரு பேக்கப் இருக்கும். இங்க வந்து மல்டிபிள் ஆக்டிவ்ஸ் இருக்கும், ஏன்னா இது லோட் பேலன்ஸ் பண்றதுனால. ப்ரீஎம்ஷன் வந்து டிசேபிள்டு பை டிஃபால்ட், வேணும்னா எனேபிள் பண்ணிக்கலாம் இது ரெண்டுத்துலயும். இங்க பை டிஃபால்ட்டே ப்ரீஎம்ஷன் எனேபிள் ஆயிருந்ததை பாத்தீங்க VRRPல. ஒரு மேக் அட்ரஸ் இருக்கும் ஒரு குரூப்புக்கு, இது ரெண்டுத்துலயுமே. ஆனா இங்க அப்படி கிடையாது. இங்க லோட் பேலன்ஸ் பண்றதுனால சப் குரூப்ஸ் கிரியேட் ஆகும். அதுக்கு பேர் வந்து AVF, ஆக்டிவ் வர்ச்சுவல் ஃபார்வர்டர். ஒவ்வொரு AVFக்கு, ஒவ்வொரு ஆக்டிவ் வர்ச்சுவல் ஃபார்வர்டருக்கும் ஒரு யூனிக் மேக் அட்ரஸ் ஜெனரேட் ஆகும். இது சிஸ்கோ ஒன்லி, இது மல்டி வெண்டர். இது சிஸ்கோல பிளஸ் இது லோட் பேலன்சிங் பண்ற ஒரு விஷயம். இந்த டிஃபரன்சஸ் வந்து நீங்க தெரிஞ்சு வச்சிருக்கணும். இன்னும் ஒரு டிஃபரன்ஸ் நீங்க ஆட் பண்ணியிருந்தா நல்லா இருந்திருக்கும். மல்டிகாஸ்ட் அட்ரஸ். HSRP மல்டிகாஸ்ட் அட்ரஸ் ஞாபகம் இருக்கா? ஒன் நாட் எயிட்டா ஒன் நாட் இது 18 வரும். கரெக்ட். இதுவும் சேம் HSRP போலவே 224.00 102. HSRP வெர்ஷன் 1 ஒருவேளை நீங்க எனேபிள் பண்ணீங்கன்னா அதுல வந்து .2 வரும். சரி, இப்போ இந்த டிஃபரன்சஸ் தெரிஞ்சா போதும். The question was, what if that F00 get disconnected? If F00 get disconnected, then also we want the router to shift. We want the active router to be R2. If R1's F00 goes down, we don't want traffic to anymore send to R1. We want to send it to R2. How can we achieve this? That's what I want to show you as first scenario. You see, right now when I say from that PC, this is PC here, not 5 is the PC. When I say trace 3.3.3.3, I can see the traffic is going where router 2. Why? Let's see what we have enabled. What is this? Duplicate address. Show VRRP. Not enabled, that is why. Interface F0/1. Let's enable HSRP now. This is VRRP's multicast address. I don't know from where it is coming. Maybe router 1 is still running VRRP. Show VRRP. Yeah. Let me remove VRRP, no VRRP 1. Now that duplicate address complaint will stop. It won't come anymore. Let's enable HSRP, show standby. Show standby. Here HSRP is there, let me remove. Interface F0/1, no standby. I'm going to put freshly. I like to start from R1. Before I start, I would like to trace once again. It's going, I'll clear the cache. And I'll try to trace, it won't go. Same case with router 4. Trace or ping. It won't go. Now let's go enable HSRP. I'm going to enable with preemption, okay? I want R1 to be the primary. Interface F0/1. Standby 1. IP 172.16.0.100. Priority 200. Preemption. I finish configuring. Now I'll go to router 2 and configure F01 standby 1 IP 172.16. Same address. Done. All right, it's over. Now R1 should become active. Okay, it is already active. R2 should go standby. I'm waiting for that. Okay, it is standby. And we know that because preemption is enabled, if I shut down from here F01, R2 will become active. R2 has become active. But when I say no shut, R1 will retain active position. You see, immediately it has become active. And R2 should have gone to standby now. It is in speak mode. Soon it will go to standby. It has come out from active. Now it is standby. But if this link goes down, if this F00 goes down, will the same happen? F00. If you shut down, even now the packet will try to go via router 1 only. But the problem is router 1 do not know the route. It went to router 2 and then it went to the destination. So it was not going via router 1 now. It goes to router 1 and comes back. It is because of ARP this is happening. I'm going to clear ARP. Then you will know the real status. After clearing the ARP, now you see I trace the route. Right? It says I'm going to router 1 and then to router 1. This interface is shut down actually. I've shut down. The packet cannot go that side. There's a simulator, still it shows green. That is why this confusion is happening. If it is a real device, it would have gone red. Line protocol might have gone down. Now, anyhow, what I'm trying to say is, it cannot show you two gateway like this. It should show you only one. You see, when I bring that interface back, it will not show you 2. It will show you only 1. Showing 2 is not good. It should be like this. Now, what I'm trying to say is, even if this F00 goes down, you want R2 to become active. How can we achieve this? You know how we achieve? I'll show you. This is a nice logic. We will tell the HSRP that is running here to monitor this F00. Monitor. If that goes down, we will say decrement the priority that you set here. We set priority 200. I'll say decrement 150 from it. So automatically what will happen? The priority will become 50 here. And I'll enable preemption here. This is by default 100. This will take over. Understand here what all we need to do. We will enable preemption on R2. Let me do that first. F0/1 standby 1 preempt. I'm not changing priority. The priority is still 100 only. I'm just enabling preemption. Now I'm on R1. Show standby. It shows that the local preemption is priority is 200. Local is active. The other router is standby. Its priority is 100. Now what I am saying is, to the interface F01, I'm saying standby 1 track. Track which interface? Fast Ethernet 0/0. See the picture at the background? Track 0/0. If that fails, decrement. How much you want to decrement? I want to decrement so that the priority on R1 F01 should be less than the priority on R2 F01. So I can say 101. If I say 101 to decrement, after decrementing, what will be the priority? Can anyone say? After decrementing, what will be the priority? 99. So automatically R2 will kick off R1 and become active. Let me show you that. Show standby. You can see here, still the local device is active and the active router is local and the priority is 200. And I have also said you track the other interface. If the state goes down only, it will decrement. When it is up, it won't decrement. It won't decrement. Now, let us trace it out. Let's see what path it takes. Right now, it should go via router 1. Okay. Now I'll go to router 1 and shut down the other port. Interface F00 port, the one which is connecting to the internet. I'm shutting down this port. I'm expecting the decrementation. Look at this. It has gone to speak from active. And router 2 should have become active now. Now you go to router 2 and ask, show standby. Router 2 says local is active because the standby priority is 99. It is not 200. It is 99 now. You can also see this in router 1 itself. Show standby. You see, the actual configured priority is 200, but right now the priority is 99 because the state has gone down. So the decrement has happened. Now trace the route. It should go via router 2. Yeah, it goes via router 2, 11. If that port comes back, see what happens. The decremented priority will be given back. That 101 will be given back. So that will become 200. And because the preemption is there, this will become again active. Now, go to router 5 and try. It goes back via router 1. And now you see here, show standby. It is back 200 because the trace is up. Like this, you can also trace on VRRP. Okay, that's the main difference. Now we are going to the new topic in this. Sorry, the last topic in this called GLBP, Gateway. Okay, now there also you have to track again. See, when R2 is active, down ஆச்சுனா தான் மேட்ரு. அது ஆக்டிவா இல்லாதப்ப டவுன் ஆனா என்ன, டவுன் ஆகலன்னா என்ன நம்ம. இப்போ இது ஆக்டிவா இருக்கும்போது இங்க டவுன் ஆனா நமக்கு என்ன பிரச்சனை? Is there any problem? No. When this is active, if this goes down, then you decrement this. ஆக்சுவலா தேவையில்லாத விஷயம் இது. ஸ்டாண்ட் பைங்க இது யோசிச்சு, இட்ஸ் நாட் ரைட் கொஸ்டின். திங்க் பண்ணி பாருங்க, அது ரைட்டா பாருங்க. இது ஆக்டிவா இருக்குது, இது ஏதாவது ஆனாதான் இது வரப்போகுது. திருப்பி இதை நீங்க சரி பண்ணிட்டு போறீங்க, திருப்பி இங்க வந்துட போகுது. எதுக்காக இதை பத்தி நம்ம யோசிக்கணும்? வேணும்னா நீங்க அங்கேயும் ட்ராக் பண்ணுங்க. ட்ராக் பண்ணி என்ன சொல்லுங்க, இது டவுன் ஆச்சா, இது 50 டிக்ரிமெண்ட் பண்ணிருப்பா. அப்போ டவுன் ஆயிடுச்சுன்னா இது 50ல இருக்கும். இங்க டவுன் ஆனது இது 99க்கு வரும். ஃபெயிலியர் ஆகுமானா ஆகாது. You understand? So you can add another router there. Another router to the internet. You can have up to 4 routers in the bundle. I have right now 2 routers only. You can have up to 4. Same group ID, same floating address you are going to give. Now the third one is gateway load balancing protocol. Gateway load balancing protocol. You see, this is an interesting story. GLBP. Both will become active. If you enable GLBP, both will become active, and the GLBP will generate 2 MAC addresses. Let's say the first MAC address is AAA. It is called as virtual, not VRF. It's called virtual active virtual forwarder, AVF. The first AVF, let's say MAC address is AAA. Second active virtual forwarder, BBP. Who will generate? The active router will generate. Let's say the priority you give 101 preemption. So whichever has got more priority, or whichever you configure first, that is the router which will generate these MAC addresses. If you have 3 routers, then it will generate 3 AVF. 3 routers. If you have 2 routers, only 2 AVF. Okay, now let us say we have 2 gateway R1 and R2, but these 2 MAC addresses are generated by R1, and R1 will say, I will be the AVF1, you be AVF2. And now BBB will be owned by AVF2, router 2. AAA is owned by R1. Now, if there is an ARP request coming to this address, AVF1 will say, take my MAC address. So according to this one, AAA is the MAC address to go to gateway. To this is the MAC address, AVF1, which is R1. When this guy sends an ARP request, it gives the second MAC address. When this guy sends an ARP request, it gives again the first MAC address. If the fourth guy sends an ARP request, it will send the second MAC address, so that equally load can be shared. Same gateway, both gateways have got same IP address. Same IP address here, 0.100. But the MAC address is the MAC address of two different AVF, two different gateways. So this guy will go via this way, this guy will go via this way. This guy will go via this way, this guy will go via this way. This is how the load sharing happens. Let me quickly show you in the lab. I'm going to remove HSRP first. Interface F01, no standby 1. I also remove it from router 2. Okay, now I'll enable GLBP. I'm on R1. The command is GLBP only. GLBP1 IP, easy no? 172.16.0.100, same command. Put that same command on R2 also. Now this will become AVG and it will have two AVF. What is AVG? That's the leader, which is going to generate the MAC address for the group members. Okay, this has become active. Okay, active, actually both are active. Here the active means this is the leader of the group. This is the one which is going to generate the MAC address. You see, the forwarder 1, this is active. R2 will become forwarder 2 is active. Did you see this? Both are active, but not for the same forwarder. Though both are same group, but there are two forwarders, two AVF. You see that? I'll show you in the command line. Show standby. Sorry, show GLBP. You can see this is the active router, the leader of both the routers. It's using this virtual IP address. And see the MAC address. This is the MAC address that is given to router A, gateway 1. This is the MAC address that is given to gateway 2. Gateway 1, this is local, used by local. Here, the next MAC address will be used. This uses the next MAC address. So they don't use same MAC address, but the IP address is same. See, for forwarder 2, AVF, this is active. Whereas R1, see, for forwarder 2, this is the MAC address, B4. Forwarder 1, this is active, B4, 0101. This is 0102. Okay, see, this is active for 0102. This is active for 0101. listening for 02 so that it can take as a backup, and this is listening for 01. What do you understand? Both are forwarding. Now, let's clear this R cache first. On 4 and 5, I would like to clear the R. Show R. This is directly connected AP. Nice. Also on this PC, show R. Clear. Yeah, I don't want to deal with this virtual PC. Now let's focus on only these two. Now I'm pinging from the first route. Ping 33333. And also I want to ping the same from second PC. Okay. And now I want to see the path. Trace 333. It goes via the first router. Trace. It goes via second router. What do you understand? The load balance happens. See, R4 goes via first router. R5 goes via second router. Show R. To this floating address, it is using 10102. Whereas here, show R. To this floating address, it is using 1011. 1001. Two different MAC address that GLBP gives because you have two gateways to load balance. If you have three gateways, then three MAC address. So in an organization, if you have 300 computers and three gateways, equally it will be load balance. 100 PCs traffic on gateway 1, 100 on gateway 2, another 100 on gateway. You understood GLBP?